In this video, we'll be going over examples for the lesson on solving compound inequalities. So here we have a compound inequality, and this is an AND inequality. So the first thing I would do is I would just add 4 to all sides, and you're left with 2 is less than 2x is less than 4, and then I would just divide everything by 2. And because 2 is a positive number, I don't have to switch any signs or anything like that. And I'm left with 1 is less than x is less than 2. So x is between 1 and 2. Number 2 is another compound inequality. This time it's of the type OR. So for OR inequalities, we just do one side, we do the other side, and then we put it together in the end. So the first thing I'm going to do is I'm going to subtract 1 from both sides, and I get that x over 6 is greater than 3. And then I multiply both sides by 6. 6 is a positive number, so I don't have to worry about switching any signs. And I'm left with x is greater than 18. Now on the right, I would subtract 2 from both sides. That way I isolate x on the left and a constant on the right. I have x over 8 is greater than 1. Now I can multiply both sides by 8. Again, 8 is positive, so I don't have to worry about switching any signs. And x is greater than 8. So here are our ORs. X is greater than 18, or x is greater than 8. But you should note here that x is greater than 18 is assumed if x is greater than 8. If x is 9, 10, 11, 12, that you need x is greater than 8 for. But for the case where x is 19, 20, this covers it. So you don't need this, because that's included in x is greater than 8. So our answer, x is greater than 8. You could also think about this with a number line. If I have 8 here and 18 here, x is greater than 8 is saying that it's all the way up here. But x is greater than 18 is specifying that it's only up here. So if we say greater than 8, it includes more than just greater than 18. But it also includes all of greater than 18. So all we really need is just x is greater than 8. For number 3, it's an OR inequality. So we have a left side and a right side, and let's get started. For the left, I can subtract 4 from both sides, which will give me x's on the left and constants on the right. So 3x is less than or equal to 7 minus 4 is 3. Now I can divide both sides by 3. That's a positive number, so I don't have to worry about switching any signs. X is less than or equal to 1. So that's what I have on the left. Now on the right, to separate x's and constants, I'll just add 3 to both sides, and I'll get that 2x is greater than 10. Now I can divide both sides by 2. And because 2 is positive, I don't have to worry about switching the greater than symbol. X is just greater than 5. So here we have 2 parts. Now we have to make sure that they don't include each other, like it was the case with the previous problem. The easiest way to do that, really, is to just draw the number line. So here I have 1, and here I have 5. There's also 2, 3, 4. X is less than or equal to 1. I'll draw here. So less than or equal to, so I shade in the circle because it can be equal to. It can be less than. And then for x is greater than 5, that's an open circle because it's not including 5. And it can be anything greater than 5. So they don't include each other. So I have to leave it the way it is. So my answer is that x is less than or equal to 1, or x is greater than 5. For number 4, we have an AND inequality. So let's just start by putting x in the middle. So I'll subtract 16 from all sides, and it'll leave me with negative 16 is less than or equal to negative 4x, which is less than or equal to negative 12. Now I have to divide by negative 4. Because I'm dividing by a negative, I'm going to have to switch these signs around. So, in the middle we have x. On the left, negative 16 divided by negative 4 is the same thing as 16 divided by 4, which is just 4. And on the right, negative 12 divided by negative 4 is the same thing as 12 divided by 4, which is 3. The signs, however, get switched. So after the 4 here, I have less than or equal to. Now I need to switch that to greater than or equal to. And the same thing goes for this one, greater than or equal to. Because you're not supposed to put greater than or equal to signs here, it should always be, as it's used in the problem, less than or equal to or less than. I'm just going to reflect everything over. So here, x is less than or equal to 4. If I read this backwards, that's what it says. So x is less than or equal to 4. X is greater than or equal to 3. So x is greater than or equal to 3. And I only say greater than or equal to in that case is because I was reading it kind of backwards. Because this saying 3 is less than or equal to x is the same thing as x is greater than or equal to 3. So here's our answer. We could also draw this on the number line if we just have 3 and 4. The solution includes 3 and 4, so they're closed circles, and also everything in between.